Hello students, in previous video we have seen kurtosis and the introduction to the moments. There are two types of moments, raw moments and the central moments. Raw moments are the moments about the origin and the central moments are the moments about the arithmetic mean. Now in this video, first of all we will see the relationship between raw moments and the central moments. So let me start what the relation between raw moments and central moments. So here for that let me start from the central moment. You know, by definition of central moment is given by what? Mu r. Mu r is equal to what? 1 upon n summation I from 1 to k, where xi minus x bar raised to r into fi, where capital M equal to what? Summation fi. Fine. Now here this is equivalent to 1 upon n summation fi into what? Here for this bracket xi minus x bar raised to r, let us use a binomial expansion. So here it will be xi raised to r minus, what is this? Here we will get rc1. Here rc0 term was there, but its value is 1. So I exclude it. So here rc1 we will get xi raised to r minus 1 into x bar plus rc2 xi raised to r minus 2 into x bar square minus plus minus 1 raised to r. Now it depends on the value of r. Here rcr xi raised to 0 and x bar raised to what? R. This is a using binomial expansion we will get it. Fine. Now let us open the bracket. We will get summation fi into xi raised to r upon n. This term will be multiplied to each and every term minus what? rc1 x bar into summation fi xi raised to r minus 1 upon what? Capital N plus rc2 summation x bar square again summation fi xi raised to r minus 2 upon what? Capital N. Fine. Minus plus minus 1 raised to r. Here rcr is 1. Fine. We will put a bit later. Summation fi into xi raised to 0 upon capital N into x bar raised to what? R. Now this bar is independent of I. His summation is depend on what? I. That's the term I taking separate x separately. Now if you this is raw moment. It is about the origin. It is moment about the origin. So this is mu r dash. This is what? Mu r dash minus rc1. The value of rc1 is r itself, but let me keep it as it is, rc1. Here this is x bar. X bar is nothing but mu1 dash. Arithmetic mean is nothing but mu1 dash. If r is equal to 1, this is arithmetic mean, that is x bar. Fine. This is mu r minus 1 dash. This is mu r minus 1 dash, raw moment, r minus 1th raw moment, plus rc2, again this is x bar square, means mu1 dash square. This is mu r minus 2 dash. Fine. Minus dot 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 plus minus 1 raised to r into RCR, that is 1. And what about this? This part is xi raised to 0 means what? 1. Summation fi is capital N. This is also capital N. So this whole term will give us 1. So this part will give us 1. X bar raised to r means what? Mu1 dash raised to what? R. Mu1 dash raised to r. Here I can write reason, since x bar is equal to what? Mu1 dash. X bar is mu1 dash. This is a reason for this. Okay. Now this is equivalent to, this is what? Mu r. The whole one will be what? Mu r. Let me write it as is. Now here let us see, in particular most of the time it is asked to us that find first 4 central moments as such the question. So let me write the value, put the value of r from 1 to 4 and let me check what are the values of them. So in particular put r is equal to 1, 2, 3 and 4. We get first of all mu1. What is mu1? R is equal to 1. So mu1 dash minus 1c1. Here 1c2, those terms are not required in that case. R is equal to 1 means only 2 terms we required. Here mu1 dash 1c1, look at here carefully. Mu1 dash minus 1c1. 1c1, that is 1. Now this is again mu1 dash and this is mu0 dash. Only these 2 terms. Further terms will get cancelled. Fine. No need of them for r is equal to 1. Okay. Now if you look it carefully, this is 1. This term is also what? 1. So we get mu1 dash minus mu1 dash, and that is equal to what? 0. So for all observations, this mu1 is always what? 0. First central moment is always 0. Here we can say for all observations. For all observations. Okay. Now mu2. What is mu2? Put up r is equal to 2. It will be mu2 dash minus 2c1, okay, into mu1 dash. Again this is mu1 dash. Here also r is equal to 2, so mu1 dash. Here plus 2c2 mu1 dash square as it is, and this will become mu0 dash. 3 terms as such. So what we get here? This is mu2 dash as it is. Here it will be, this is what? 1. Its value is 1. 1 times mu1 dash square. Mu1 dash what? Square. And this is 2c1. Sorry, 2c1 is 2. It is 2 mu1 dash square, and this is 1. This is 1 mu1 dash square. This is also 1. So mu1 dash square. So finally what we get? This is mu2 dash minus these 2 togetherly we get only 1 mu1 dash square. Okay. Next. Now next one will be mu3. What is mu3? Mu3 is mu3 dash minus 3c1 mu1 dash into mu1 dash into mu2 dash. Fine. Plus 3c2 Next, mu1 dash square into mu1 again dash minus 3c3. What will be the next term? Mu1 dash cube into mu0 dash. As such we will get. So that will be mu3 dash minus 3 here 3 mu1 dash mu2 dash. Fine. This one 3c1 will be 3. This is also 3. Okay. Sorry, this is 3c1 will be 6. This will be 6 minus, sorry, plus 3 mu1 dash this is 3. This is also 3 and this is 1. Sorry, I am making mistake. 3 mu1 dash square into mu1 dash minus, this is what? Mu1 dash square into mu1 dash means what? Mu1 dash cube, and minus, this is 1. This is mu1 dash cube. Okay. Now, finally, what does it? It will be mu3 dash minus, this is 3 mu1 dash mu2 dash as it is, but these two togetherly we get 2 times mu1 dash cube. Okay. Next, mu4. What is mu4? Mu4 is mu4 dash minus 4c1 mu1 dash into mu3 dash plus 4c2 mu2 dash into mu1 dash square minus 4c3 into mu1 dash into mu1 dash cube plus 4c4 mu1 dash raised to 4 into mu0 dash. Now, what does it? This is mu4 dash minus, this is 4 mu1 dash mu3 dash. This is 6. 6 times mu2 dash mu1 dash square. Okay. This is 4. 4 mu1 dash into mu1 dash raised to 3 means mu1 dash raised to what? 4 plus this is 1. 1 times what? Mu1 dash raised to what? 4. So this is equal to what? Mu4 dash minus 4 mu1 dash into mu3 dash plus 6 mu2 dash into mu1 dash square, and this will be what? Minus 3 times mu1 dash raised to what? 4. These are the relations between what? First 4 central moments in terms of first 4 raw moments. So here the central moment of odd order for a symmetric distribution are always what? 0. For symmetric distribution they are always 0. That thing also you should note. Now let me write these things as a note once again. These 4 relations you have to keep in mind. That's why let me write them as a note. So note here, always remember mu1 is what? 0. Mu2 is what? This one. Mu2 dash minus mu1 dash square. Mu3. What is mu3? Mu3 is this term. Mu3 dash minus 3 mu1 dash mu2 dash plus 2 mu1 dash cube. Next, mu4. What is mu4? It is mu4 dash minus 4 mu1 dash mu3 dash plus 6 mu1 dash square into mu2 dash minus 3 mu4 dash raised to 4. These one you have to remember. Second note, what I say, the central moments of odd order for a symmetric distribution. Symmetric distribution are equal to what? 0. They are always 0. Now let us see example, and later on we have to see Pearsonian coefficient to measure skewness and kurtosis using moments. Example, given that mean is 1, mu2 is 3 and mu3 is 0. Now the question is that obtain first 3 raw moments. Raw moments means what? We have to find first 3 raw moments, means mu1 dash, mu2 dash and mu3 dash we have to find. So for that we will use these relations. Look at now carefully solution for this. What is given to us? Given mean. Mean is nothing but mean, if you remember, mean is nothing but mu1 dash. Mu1 dash is what? 1. What is given? Another thing, mu2. It is central moment, 3. This left hand side is given to us. This part is given to us. So this one we can easily find. Then next one, what is given? Mu3. This is 0. Again this one given to us. Once we find this, we will use that one also here. This one we will use it here. This is known. So this one we can easily determine. Now look at it carefully. Mu1 dash is known, means first raw moments is known to us. Now the question is what? Second. So mu2 is what? Mu2 dash minus mu1 dash square. So from this we can write mu2 dash is equal to what? Mu2 plus mu1 dash square. So mu2 is how much? 3 plus this is what? 1 square. So 3 plus 1, so that is equal to what? 4. Now next one, mu3 is equal to mu3 dash minus 3 mu1 dash mu2 dash plus 2 mu1 dash cube. And that is it. That gives us mu3 dash equal to what? Mu3. This is plus 3 mu1 dash mu2 dash minus 2 mu1 dash cube. These two terms I have been taken on left hand side. So now this is known. These are also known to us. So this is 0 plus 3 into mu1 dash is 1. This is 4 minus 2 into this is 1 cube. So this is what? 12 minus 2. So this is 10. So in this way we have been found first 3 raw moments, that is mu1 dash is what? 1, mu2 dash is what? 4 and mu3 dash is what? 10. This is our answer here. Okay. So as such, using these relations, either we can find out the central moments or the raw moments. Now Next thing, let us see Pearsonian coefficient to measure skewness and kurtosis using moments. So what are the results for them? Now for measuring skewness and kurtosis and for studying the form of frequency distribution, Carl Pearson has suggested some coefficients which are independent of the units in which the data are expressed. These coefficients are denoted by beta 1, beta 2, gamma 1 and gamma 2, and they are relative measures of skewness and kurtosis. Now, if mu r are the central moments, then beta 1, beta 2, gamma 1, gamma 2 are expressed in terms of these central moments. So let us see them. Here, let me write these coefficients. These coefficients are denoted by what? Beta 1, beta 2, gamma 1 and gamma 2. And they are the relative measures of skewness and kurtosis. Relative measures of skewness and kurtosis. If mu r, that is r is equal to 1, 2, 3 and 4 are the central moments, then beta 1 is nothing but mu 3 square upon mu 2 cube, and beta 2 is mu 4 upon mu 2 square. Also, gamma 1 is square root of beta 1 and gamma 2 is what? Beta 2 minus 3. Now the algebraic signs of gamma 1 is same as sign of mu 3. Okay, the coefficient gamma 1 measures the degree and type of what? Skewness. Gamma 1 measures the degree and the type of skewness of the distribution. Now, how does it? So, interpretation for that. If mu 3 is 0, gamma 1 is also what? 0. Then distribution is symmetric. That time the distribution is symmetric. Okay. Next one, another thing is what? If mu 3 is less than 0, then gamma 1 is also what? Less than 0. Then distribution, in that case, the distribution is obviously what? Negatively skewed. Distribution is negatively skewed. Okay. Next, mu 3 is greater than 0 and gamma 1 is also greater than 0, then distribution is positively skewed. The numerical value of gamma 1 gives the extent of the skewness. The other coefficient gamma 2 measures the kurtosis. Now let us see that part. The other coefficient gamma 2 measures the kurtosis of the distribution. So how does it? Let us see. If beta 2 is 3, here look at, if beta 2 is 3, 3 minus 3 will be 0. The distribution is mesokurtic. Means what? Gamma 2 is 0. Therefore, the distribution is mesokurtic. Okay. Now next thing, if beta 2 less than 3, then gamma 2 is also less than 0. That time the distribution is platykurtic. The distribution is platykurtic. And beta 2 is greater than 3, that time gamma 2 is also greater than 0. The distribution is what? Leptokurtic. So first of all we have to find out beta 1, beta 2 using central moments, and then gamma 1, gamma 2 to check the skewness and the kurtosis of which kind. So using simply central moments we can easily determine these, we can easily say about the kurtosis as well as the skewness here. Now here we will stop for this video. In next video we will see examples on these one. Thank you.